Text, Indeed. Reliability during technical churn. Nick Whelan, technical lead Indeed engineering. A man stands on a stage in front of a large TV screen displaying a slideshow.
Hi, my name is Nick. I'm a tech lead here at Indeed, been with Indeed for a while, and had an opportunity to work on a lot of great, different, challenging problems here at Indeed. But today I'd like to talk about kind of maintaining reliability and service level objectives, which I'll just refer to as SLOs going forward, during technical churn. So the first thing we need to ask ourselves is, what is technical churn?
Slide, a picture of hands typing on a laptop.
So I think many people, when they hear technical churn, they might just be familiar with code churn. If you aren't, code churn is really the idea of rewriting your existing code, especially by the same developer, when it doesn't really change performance or functionality. So maybe you're just trying to make a loop a little more elegant by removing some variable definitions. Not necessarily beneficial. Sometimes it could be, but maybe not.
Slide, technical churn, a list.
However, there's also numerous other types of technical churn that we have to deal with as software engineers. One example is just changing data schemas or indexes. Perhaps you've found that there's a new use case for querying your data, or your tables have expanded greatly in size. And so having to diagnose that, talk to the users, and figure out what indexes you need, that could be technical churn. Really anything that doesn't produce new features, I kind of see as technical churn. In some cases, performance fixes as well as bug fixes aren't necessarily churn. But ideally, we want to be working on new features that are improving the experience of, for us, job seekers. Changing data infrastructure or data sources. So this could be moving your database from one version of MySQL to a new version, or it could be changing your underlying data structure entirely, where perhaps you've had a relational database now and you're transferring it to a NoSQL store. Finally, one thing that we're going to look at here is migrating to a new infrastructure. So this could be going, for our case, what we had was a prototype and kind of a prototype environment, essentially a glorified dev environment behind our firewall. And we really wanted to move this into our production data centers. So on that, going to keep talking about maintaining this reliability kind of during migrations, and specifically during application migrations.
Slide, single data owner principle.
So there's a few things that are going to help us do this. And first, I want to talk about the single data owner principle. It's really the idea that a single team or application is the only thing that has direct access to your data. So if other teams or users would like to get access to the data, you can provide a service with an API, and that's just contacting your data. So as long as you maintain the contract between your API and your users, you can change underlying data structures, even the type of database that's going to be used, the server it's on, what have you.
Slide, order of operations.
The order of operations during a migration, we're going to find, is very important. At its most base case, I think it's pretty obvious that you don't want to launch your application before you actually have your database revisioned and before your data is there. So that's something that's going to be important to consider.
Slide, no broken links.
I think for us, it would have been really easy to dismiss broken links. We didn't really have that many users, but I think it's really important to kind of maintain a user experience where you don't have any broken links. For us, this is something we manage in our application, just creating simple 301s and 302s. But it's also something you could do at your web server level as well. And depending on your application, this could actually have material effects on your business by affecting things like search engine optimization.
Slide, monitoring SLOs.
Another thing that's really important when you're doing a migration, if you're going to maintain your SLOs and make sure they're good, you've got to be able to monitor them. Ideally, it's something you can be able to see in real time. We monitor a lot of our metrics and service level objectives using a software as a service called Datadog, which allows us to ping those to a third party and really see kind of a time series of them in real time. Some other options out there might be Prometheus, which is kind of an open source service that you could host yourself. Provides a lot of the same features.
Slide, logging and error reporting.
You want to have good logging and error reporting. Now, this doesn't mean you want to be logging literally everything, because if you've got too much noise, you're not going to really know what's going on. For us, we were lucky enough to be able to leverage a service called Sentry Labs. And so when an uncaught error was thrown, we were able to get immediate logging. They could also be aggregated among different users of our application, allowing us to act quickly and immediately if there was a problem.
Slide, automated validation of consistency between new and old instances.
And one thing that also is beneficial for us was having some automated validation of the consistency between our data sources. So from the prototype to our production, you can't have a developer sitting there and querying it, making sure things look good. But if you've got any level of scale, it's going to be very hard for just one or two, even two people to kind of be validating that. And their time can be better spent responding to actual issues that arise. But one thing to note is really none of this is free. And in order to be able to leverage it in a migration, it's something that you should think about when doing product development. If you have violated the single data owner principle, it's not going to help you to know about it once you're migrating. At that point, you may have numerous teams and applications going to your database directly, and it's already too late. However, you can always add things like monitoring your service level objectives at really any time, I think.
Slide, in practice, from prototype to launch.
So now I want to go specifically in our case, where again, we took this prototype, which was a Django application with a fair amount of use. We kind of had two sets of users, one who would use it daily, and a larger set of users who would use it once and interact with the recruiters in different ways.
Slide, challenges, a list.
So some of the challenges that we had. The users had really just been moved to this prototype. Before that, our users, who admittedly were not very technical, had been moved from a pretty manual process, mostly used in email, and really coordinated with some of our product managers. So we really wanted to make this transparent to them, because they weren't going to be happy with another change. I mean, no one really likes a change of the status quo. For a lot of our job seekers, it's likely that they wouldn't return if anything came down. It was kind of a once and done type of thing, and if the links are broken or the server's not up, it's unlikely they would come back, and that's just not a good experience for our job seekers. We had multiple webhooks from third-party applications that needed to be responsive. One of them was a bit resilient in that it could retry if it got an error or a non-200 response code, but one of them facilitated real-time communication, and if that stopped, then we would definitely break our service level objective of all of our customers being able to contact job seekers kind of through some obfuscated means.
Slide, advantage.
One advantage we did have, as I mentioned, was the single data owner and user. We just had one application that could talk to the database. So as long as we maintained the contract of our API, we didn't really have to worry about what we were doing underneath. So let's take a look at how we actually executed a plan.
Slide, provision production resources.
So the first thing that we needed to do was provision these production resources.
Slide, two boxes, titled Prototype Infrastructure and Production Infrastructure. The prototype box contains a box labeled Prototype Application, with an arrow pointing to a 3D cylinder labeled Prototype DB.
So here you can see we've got our prototype infrastructure, again, kind of glorified dev hardware behind our firewall. First thing I needed to do was reach out to our data team to get a database provisioned.
A cylinder labeled ProdDB appears in the production infrastructure box.
That's one thing we don't quite have set up, where we still need to integrate with our data team to kind of get that going, but it's a pretty straightforward process, and we had it going in a day.
A box labeled Production Application appears in the production infrastructure box.
From there, I was able to provision our application ourselves on our Mesos cluster. Once I was able to validate that all the properties were good between the prototype and the production, I was able to wire it up. And so now we've kind of got the step one of things being provisioned, but as you can see, we don't have any data. So what we wanted to do was create a baseline in our data in the production infrastructure and build on that as users were transferred to the new infrastructure.
A box appears between the two infrastructure boxes, labeled Baseline Creator.
So to do this, we created a new application that would talk just directly to our APIs from the prototype to the production application. Again, not actually writing to the database directly. So we did this, and we were able to get to where we were in our prototype.
The baseline box disappears.
And from here, we got rid of our baseline creator. But of course, as people continue to use our prototype, we need to synchronize those updates to production. So as I mentioned, we were a Django application, and one thing I love doing when I can is leveraging open source.
A box appears in the prototype infrastructure box, labeled Django Synchro, with an arrow pointing to the ProdDB cylinder.
I could have made something like this, but it was great to use something that already exists. In this case, it was a kind of Django application called Django Synchro that would take updates from one Django application and then write them directly into another database. Now, this is a little interesting because we are somewhat violating the single data user principle. I think that's okay in this case because it was for just a single use case, and the amount of work it would have taken to create our own thing wasn't necessarily worth kind of following that and being rigid in all cases. So as people continue to use the prototype, our production DB would fill up with those updates. So now, pretty straightforward, we can switch our subdomain DNS to production. At this point, we've got some new users using our production application, but because of the nature of DNS, it hasn't necessarily updated all of our users to this production infrastructure. So we need to continue running our synchronization process as we go through. This is the point where it becomes very essential to communicate with your team, your SREs, and your customers if you need to set expectations. Also, you can't just set it and forget it. You know, we hit play, but it's not done yet. We need to make sure that we're monitoring those things we talked about earlier. So we want to confirm the provisioning of production, that this DNS update worked. This is where maybe having a private page that can tell you, this is the exact server I'm on, this is the version I'm running. Shouldn't be open to the public, but perhaps something behind your own firewall you can access to verify that.
Slide, monitoring launch and decommission, a list.
We wanted to verify user activity. We did that using Datadog and just looking at our application logs. And then we use Sentry again to really monitor our errors and our logs, as well as just kind of going through and grepping our log stream. We have really great availability from our logs through some tools that our SREs and DevOps have made. And then finally, we can verify that all activities really ceased on the prototype. So really no user activity logs, nothing really hitting it. And at this point, users are gone. We can get rid of our prototype infrastructure, really reclaim those resources, and iterate on our product.
Slide, execution leads to success.
And so having this execution led to some success. We're able to do this without any transparent effect on our users or the job seekers, so kind of recruiters and job seekers, which was a big advantage. All right, thank you.
Text, Indeed. Thank you. Nick Whelan, Technical Lead, Indeed Engineering.